So this will give you two plotting, right? As you can see, one for each because we say by group or by treatment. So it's giving me a plotting for patient who is given treatment A and for patient who is given treatment B. Just by looking at the two, you can compare, right? Look at that.
Not the same intercept.
So there is more reductions happen to the treatment A, correct? Specifically after week 1, that you see the reductions. So now this is the plotting for every line here. As you can see, this requires different various covariance structures cannot be modeled by, yes?
But no common intercept.
Yes, it is not common intercept.
It's random. Intercept and random.
It could be, yes, there is a random intercept involved. For this group, the intercept may be the same, yes.
And
But
this
for,
way you can accept.
yes,
We could most likely do.
right. But for this group now, you see
No.
that? Mostly they have,
Even random variation.
yes, there is a random variation involved.
Yeah.
Look at this.
Yes, yes. Something wrong.
This is, I'm not sure if it can be explained. Or from week 4 till week 6, that huge jump. Look at this.
Can we explain it as missing data? Can be given like this plot?
I'm not sure, but whether there is a continued observation in here. But it's very interesting. There is a variation in their response to the treatment.
Yes.
So which one is it?
Treatment A, you see these reductions?
Yeah.
Go until blue 10 here, which is in treatment in placebo. You don't see that, right? Look at the reductions. It's go away.
Yeah.
This is a 10, let 10, which is good.
Could be significant.
Most of them they have in here
Week 6, very bad.
huge reductions, but for the placebo reduction only, there maybe little about 20s and less than 20s, and then
So the graph, the first graph, we could say that of using treating A or treatment A during the first week for
Yes.
this parameter
Yeah.
will reduce about maybe absolute reduction is almost 10.
yeah,
or
that
15.
clinically from like here you go from average. If you try to look at the average, it would be here.
Can we plot the average?
Yeah, you can. I mean,
By coding.
it is a fit. This is why you're trying to use the covariance structures to have this line fitted. So now, even there is a random intercept model, there is a random slope model, there is a random intercept model, both of them. So that means you're treating each patient separately as a line. You don't try to create a common line for these. So there is more modeling that you can, instead of having one line for these, the average, which is maybe comes here, the middle, you can have this model, so each line represents itself. And you can program it using.
في الكتاب لما نكتب for example شيء مثلا نقول in compare to average أفضل something to compare with a reduction. أنا أتكلم
No, the reductions, you would be interested only how the treatment reduce the lead in treatment A compared to treatment B. You see that? So, and once you calculate the average treatment, the average lead for each treatment, then you'll be able to compare which one is better than the others. So at the end, even the comparison, it goes based on the average itself.
But in this situation, until now, we cannot say it's this difference is statistically
No, you cannot say.
Other
You can say there is some, we observe some reductions, but we don't know whether it's significant or not. Yeah. So now this is the line plot that you have seen. Yeah. The next, after we have seen the line plot, we know that the variance could be different over time, right? We know that the repeated measures ANOVA, repeated measures MANOVA may not be a good model for this data. So we need to move to the variance covariance structures that can be modeled. So what we use here, we have different variance covariance. We already studied yesterday, last week.
Unstructured.
These are 5, and there is more than 5. I think there is 7, 8. So we can model each one and see at the end which one is better fit to our data. Okay. So we're gonna run a code for each one.
ما في أداة كذا تسوي لك
There is
زي
a
ما أخذنا
measure.
regression step 1 و step 2 بعدين تعطيك the best.
Yeah, there is easier than steps when there is a parameter that you can compare.
All of them?
models together.
and give it to you the best fitting model.
Right.
Okay.
So, but you need to remember here, if you want to run the unstructured, you have to say just type equal UN. It's unstructured. That means you don't have specific assumption. If you try to run compound symmetry, remember compound symmetry? This is just a repeated measures ANOVA. Even if you wanted to run this, you just have to say type equal CS. And if your data complete, you don't have a missing data, the mixed model will give you exactly the same as the repeated measures model that we modeled before. That given that you have a full data, you don't have a missing, so you expecting to have the same result. Now this is called first autoregressive. In SAS we put type equal AR parentheses 1. Toplets we have to say just type equal TOEV. For various component we say just type equal VC.
But what's the assumption?
For each one, yeah, there is some sort of assumptions. It works with a different. Remember the matrix? The matrix for the
Various
compound
covariance.
symmetry.
Okay.
For the compound symmetry, if you remember the matrix, how it's given?
Compounds.
The matrix.
Yes.
Variance covariance matrix?
The various covariance matrix.
Okay. I
Yes.
remember.
Do you remember how it's given?
5 by 5.
It's all fixed, right? Diagonal are fixed. Off diagonal is changing, is given one parameters. So now similarly here, for these unstructured, every parameter in that matrix is different. See that? So because this is unstructured, something like this. Maybe you give it sigma. If I present it as a D, for example, sigma, so this would be D12, this would be D13, D14, so each one having different level of variance covariance, and same thing for the other one. This is unstructured modeling. For first autoregressive, I'm going to go through each one of these in detail. So if you allow me to. So we're going to get to the first one, which is the compound symmetry.